You can learn a lot from tutorials, but until you try to apply what you've learned, well, it's just not clear what you really know. I typically try and build out my own simple app to see if I can apply what I've learned to my own design. I'm sharing that process with you guys here. Not a tutorial, it's just the beginning of my journey with Couchbase. So why Couchbase? It's not Mongo. I don't have anything against Mongo, but I use it every day. I could get a free local install that's fully featured, has some interesting storage models, and pretty well documented Go SDK. In-memory data services were something that caught my eye. Go quick start with Couchbase was pretty comprehensive. I learned a lot from it and worked through it. So it really gave me the basis to go forward with my own app. So if you remember our entity model from part 1, this is it. And what I'll concentrate in on is the people and organizations entities in this little test app, and see if I can get basic CRUD going and some selects and see what kind of issues I run into trying to get this implemented. So we want to get a clean pattern for create, read, update, and delete. We want to make sure our data model makes sense with this technology, and we want to figure out good ways of organizing our code. Decided to put all the operations that I wanted to do inside of my main function. That way I could just execute them all at once, and then I could set breakpoints in my individual functions to see how they were operating and see if they were doing what I expected them to do. So doing that led me to a couple of helper functions that I know I'll need, and most everything in the Couchbase operations needs a connection and a bucket. So I figured those two helpers would be something that I'd move forward with. So now we're to the meat of things, the CRUD, create, read, update, and delete details. So from the aspect of insert, update, and delete, those were easy peasy. If you're familiar with any NoSQL database, this is instantly recognizable as the pattern you would use, whether you're in Couchbase, Mongo, or whatever. Even get by ID feels really familiar. It's simply a function we're passing in an ID, and since we're using a predictive key, that's just a couple of lines of code to do that. So nothing really unexpected there. Now, when it comes to more complex queries, it seems like we're locked into using Couchbase's structured query language variant. And that's probably a real selling point for someone that's coming from a relational database. Gives them the warm and fuzzies of familiarity, I guess. Problem I have is that it's forcing us to have executable code embedded in a string literal. I've been bitten too many times by query strings that have these bugs lurking in them that should have been caught by a compiler. Now, I did experiment with a reflection function that allows us to limit the complexity of a query string by getting as much as we can from just a reflection into the struct and reading the JSON tags. I think that could minimize the risk. We can certainly add tests around that to make sure that we at least the data structure matches the structure of the struct itself. What I would like to see that I didn't see was the ability to do partial key searches. There are cases when I can create a predictive key that I should be able to get a result set based on part of that key. And and what I'm talking about there is if I use a predictive key that's generated with an increasing level of specificity, Take, for example, I worked in television ratings. I could key a given quarter-hour rating in terms of a key like a survey type, a market area, a station code, a measurement stream, year, month, day, hour, all the way down to the quarter hour. So I would have something to the effect of monthly 101 for the New York market, 5601 for a specific station like WNBC, L1 for Live Plus One, 2024 for the year, 10 for the month, 15 for the day, and then 12:15 for the hour and quarter hour. So, in a database technology that supports a partial key match, I could just ask for monthly 101, 5601, L1, 2024, 10:15, and get the 96 quarter hours that belong to that day. And then I could do math on those 96 rows without having to write any kind of SQL string. And that sort of approach is kind of burned into my medulla oblongata. I had that in Big Table and BigQuery, so I kind of missed that and wish that were something I had available. And maybe it is available and I just don't know about it, but I did not find it. The relationship between people and organizations. An organization can have many people. So in a relational world, you might be tempted to link up the people within the organization. Well, that becomes an unbounded array, and that's not going to be good for a storage model, because that'll mean that document can grow without bound, and that's not going to be scalable. So I kind of flipped the script and have the organizations within the person entity. That way, in this particular application, a person is only going to be part of a handful of organizations. So while it's technically an unbounded array, typically very, very small. So the query pattern I came up with is a where-in clause, which in relational databases is typically something you avoid. We'll see if that's the case in this technology, but it'll be a good first stab. So that got me to where I needed to go as far as wanting to use this to tackle a larger application. So in the next episodes, we'll build out a gRPC service that implements a lot of this. Maybe not exactly the same way, but it'll be another refinement of what I've worked out here. We'll push a lot more data into the Couchbase instance. We'll refine our approach based on what the performance that we see, and then we'll build out a query service to test out some of the other query methodologies that Couchbase has. There's a lot more technology there in search that we'll want to explore, and we'll explore that in an independent service that's dedicated to that. Thanks for watching. Stay tuned for what's coming next. I'll see you then.